Thank you. I think that's a really short order. I'm just going to solve all of your code quality problems. Give me 30 minutes. That's all I need. Yes, very realistic. Thank you for the high expectations. And good afternoon, Belgium. Good afternoon, Antwerp. Good afternoon, Full Stack Europe. Lovely to see you all. How are you all doing? Come on, guys. You just had a break. You just heard about being productive and all that. How are you doing? Better? I've heard better. Come on, one more time. How are you guys doing? Yeah, here we go. So, my name is Keerthana. You can be KK. You can call me KK. That's fine. I live in Germany now. I've accepted it. I'm originally from India. I am a web developer. I've been in this field for about 5+ years, and I like to talk about technology. And if you accidentally talk about superheroes near me, I will eat your ear off. So that's me. And here I am to talk about code quality with you. And if you are somebody who works with software, we know that this is an essential part of our ecosystem, right? We all want to have the best code base, right? That's the idea. But when I come in and when I talk to you about code quality, I'd like to start with some assumptions. I'm going to assume that you all have some level of professional coding experience, right? That's be a baseline assumption that I start with. I'm going to assume that you have some experience with Scrum or Agile or some kind of a methodology like that. And I'm also going to assume that here I'm going to give you some tips, but not all of them fit everybody, right? Take what you can, but this is not a one-size-fits-all kind of a technical talk. So please come with that, and please understand that these are all case studies and tips that I think for. So I want you to know that's what I'm presenting here, right? And the main core of what I'd like to talk to you and make you guys think about is whose job is code quality? Let's take a beat. Whose job is code quality? If you are in a standard kind of a team, usually you have a team of developers, and then you have probably somebody in charge. You have a tech lead, you have a product owner, you have a senior engineer who's in charge. So ideally, you'd say, well, they are the senior engineer, they're the person in charge, TM. So it's the quality of the code base is on one particular person. But I would like to believe that code quality is something that, as a team, we all contribute to. It's not a state of perfection that we reach. At one point of day, we wake up, code quality has been achieved. Yeah. No, code quality, even if you start with the best of code bases, once you start contributing code, once you start putting code in, we need to maintain it. And I would argue, you never start with a great code base, right? I'll give you an example. Think about the first time you build something. The first time. What are you thinking about? I want this thing to work. I want it to work. I want to have zero compilation errors. I just want the thing to say hello world, right? So are you really thinking about code quality? No. You just want it to work. So I would argue that any project when you start, it doesn't really start with great code quality. It starts with things work. So that's why the process of code quality is important. And I believe that it's a process that every single team member contributes to. And today, that will be the philosophy I follow. And the next 5 points I talk about will be the 5 different ways in which we can maintain code quality in a code base. Are you guys with me so far? Yeah, I see some nods. Okay. So, the first point that I think is really important with code quality is tracking tech debt. Tech debt is a reality in every single code base I've seen. There is some amount of tech debt. So I worked, as I said, I'm from India. So I've worked with about 3 companies in 2 continents, and I've seen like different varieties of teams. The first company I worked for an offset of GE, right? And GE Oil and Gas, they had, for that one company, 72,000 people employed, right? You're nothing when you're a part of group of 72,000. You're like lesser than nothing. So I've worked in teams where, of course, I didn't work with all of the 72,000, but it's been a big team versus the team I work right now, it's a team of 20 people. So I've worked with different types of groups, different styles of leadership, and I've seen these things in different case studies, and all of them have tech debt. So how do we tackle tech debt? How do we define tech debt? I would say that tech debt is very, very personal. It depends on what the team is. You as a team can decide that what you would consider as tech debt would not be something that a different team considers tech debt. So that is something that I think every team should define what it is. And here are my few key things that I look for with tech debt. So, what do we do with handling tech debt? I would say create a tracker of sorts. So the last time we did this, we had two parts to this. We had like a markdown document where we wrote, okay, this input field, for example, this does the custom validations are a bit wonky, that is tech debt. Right? We had moved way past the input fields and the validation, but it was not working as intended in some cases, so that we need to fix tech debt. Right? But we moving on, and different parts of the application had different such tiny things that we will fix on a rainy day. That would be what I describe as tech debt. Tiny things we fix on a rainy day. So the first thing I would do is to list all of them. I, Ideally, we would have that if you use something like Jira, right? You would have an epic in it. That's why I put epic or a document. So ideally, you would have an epic in which you list out all of these things. Now, why should you list them out? So that it's visible. It's visible to everybody in the team, not just to the person who built that input element, but to the entire team, it's visible. Okay, here is where we have the problem with that little validation, right? And the next time you do something in that area, your product owner can take a look and be like, oh, yeah, we have this thing tech debt to solve. So we can just align that with the next item that you have to build in that area of the code base, and hopefully, if it's not too big, we can solve it in the next feature that we ship. So making it visible and having a group understanding of what tech debt we have, I think that's really the first step to solving tech debt, or at least to reducing it to a manageable size of what we have in the code base. Now, another thing that we implemented that I think went very well for tech debt is that, again, I'll go back to the example I mentioned. We have an element that's not working correctly, and we have listed it somewhere. We have a markdown somewhere in the code base where we have listed, okay, this is part of the tech debt that we have. So if we can connect that to where the code is, add a little comment so that whenever somebody visits that code, it says, hey, check this issue number in our tech debt document. So now, even though you don't comment it directly, you know where to look. You know exactly where it's written down, and the next time somebody touches that code, it's there. You can understand that this is the part that needs to be fixed, right? So this might not work for your team. You might not be using Jira, you might not be, and most of my examples will come, like Markdown, for example, probably comes from my web development background. So you might need to adjust this, but I'm just giving you ideas of how I'm tackling this topic. Yeah, so that's the first step. How to manage tech debt? Make it visible. Make it have a list, or make it visible for the entire team what the tech debt is. Next, the tools that work for you. Now, here is where my web development credentials are really going to flash out, right? So what do I mean by tools that work for me? So coming from as a JavaScript developer, yes, I see some people like, oh, JavaScript. Yeah, I know, but we still have to work with it. So if you have something like a linter, I like to use ESLint. I also use Prettier. So those are some things that I feel in my code base, it brings a sense of order, But you might be coming from a different background. So here are some of the tools. I think is very self-explanatory, so I'm just going to list the tools. So earlier, past in my past, when I worked with non-web stuff, I know that SonarQube exists. I don't know how popular it still is today, but I assume you can still scan your code and SonarQube still pops up saying, hey, this does not look good. So whatever tool it is that works for your code base and it helps you maintain code quality, lean into it. Now, one thing I've seen for all of these tools is that in a team, different people might use different tools. And of course, you can't use front-end tools for a back-end code base. That's obvious, right? But I still think it's important to have that discussion between the teams. If you have a front-end team and a back-end team, have that discussion. Talk about which tools you use and why, and try to see if you can use somebody else's tools. See how well it works for your workflow. I think it's really important that we experiment with different tools and take that initial step to figure out what really works for us. And the last point for IDE extension, I worked with multiple IDEs, and I know, for example, right now I use Visual Studio. Previously, I used to use the WebStorm from JetBrains. And I know that each IDE environment has their own extensions and their own things that helps with code quality maintenance, and they do scanning and all those things. So dig a bit deeper into your IDE and what kind of features and facilities it has. It might have things that you've not heard of. So I think it's really important that you take that time to check in and see what kind of extensions that you can use. It really helps you with your workflow, right? So the next part is optimizing your code review. So again, I'll go back to the key point I started this entire presentation with. I completely believe that code review is a key part of the team of building software, and I think the responsibility of having good code is a team effort. So code quality maintenance, I think this is a key part of that, because when you are going to submit your code to a code base, code review is the step right before that. So that is really the last step before new code is added in. So you really want to stress on how important code review is. I'll give you an example. Different companies, different teams are of different sizes. I worked in a team where I was a part of multiple agile teams that handled the same feature. So there were about 20, 25 of us, right, working on the same feature. The current team I'm with, as I mentioned, the entire company is only 20 people. So the entire dev team is 7 people. You have 2 people doing front end, 2 people doing back end, 1 guy who does everything, and 1 person who's a tester. Only 6 people. Is code review really that important when you have only 2 front end people? No, not really. Wrong. Still important when you have only 2 people, because that's when you can have the most disconnect between people, right? When you have 6 people in front end, there's a chance that something that one person misses, the other person can catch, because there's 6 people. But why do you have to do a good code review? Because you want to know what's happening, what the changes are that are happening in your code base, right? So once you do a good code review, even if ideal case scenario, the code that you've built is the best code, best design, everything's good, right? So the other person just evaluates it, and they're like, okay, good, no comments. But more likely, it's gonna be, yeah, it's good, but I think you've built this for when you have only one input at a time. How is this going to handle when we have multiple input streams? So there are things that we as developers, we just don't think about, and it would be nice if somebody else evaluates it. That's my first part. The second part of it is something called the bus factor. Has anybody heard of the bus factor? Yeah, some people have. Yeah, clearly, you guys are pros. So the bus factor, for all those who don't know, is if one person in a bus dies, or if one person gets hit by a bus, I'm not sure anymore, but if your team has somebody hit by a bus, how well will your team survive, right? And if you have 2 people handling front end and one person dies by a bus, all of the information that only that person had for some reason is lost with them, right? So that's why you have good code review policies in place, so that the information is not siloed into one person, and you have an idea of how your code base is getting updated. So reviewing the current code problems. So there might be some ways in which, especially if you started off with one language. For example, I think a lot of people start off their career with one language, and then they transition into another based on what company they are in or what project they are in. So especially you might bring in some coding methodologies, some coding strategies that might not be optimal to the language or framework that you're working on. So having that kind of code problems pointed out to you, I think that's good. One key thing I'd like to emphasize when I give code reviews or when I like to receive code reviews is the specificity of the feedback. It's very important that, especially when you give some kind of negative feedback, to be like specifying exactly what's going wrong. So in my previous instance, I said, hey, this design is not that great. Now, if I stop at design is not that great, I'm not explaining why the design is not great. But if I say, hey, this design is not great because it does not handle concurrent inputs, multiple concurrent inputs, then that's specific. That's exactly where they know how to check and how to fix it. So try to be more specific when you give code reviews. And at the end of the day, when you give a code review, there is always going to be points of difference. I'm going to design the system in a certain way, and maybe you are going to point out, yeah, it doesn't handle concurrent input streams. And I'm going to say, we don't need it to. That might be too much. It might be too much of a performance load if I handle something, but the system or the feature itself is not designed for multiple concurrent inputs. So why would I design it for that? So there's always going to be at some point points of difference, and you might want to discuss that through. That's the strength of a good team, is that you have differing points of view, but you can handle it. So that's where code reviews comes into play. And I understand that each of these points, for example, the tech debt, the code review, each of these are points in which I can do a 30-minute talk about that point itself. But this is just an overview of how you handle it. And each of these things, as I mentioned, you can take what works for you. Maybe you already have a good code review system set in place. Then this point itself is not for you, right? This is just an overview of good practices so that we have good code quality in our code base. That's what I'm running through. So the next part, I would say, and this is a really key one, is to reevaluate your testing philosophy. Now, sometimes testing philosophy is something that it's born out of how we have already implemented this, and it's just, oh, well, we started testing like this, and it remains. I've heard that a couple of times at the different companies I'm working on. So I'm going to give you an example. If you're working on a website, which is a bit more UI heavy, right? There is a chance that you can have something like, for example, the UI has multiple date pickers, multiple different types of inputs. And would it be best to test each input as is, to have an unit testing for each component, versus would it be better to have an integration testing, how the feature works itself based on the different inputs that it has? I would argue that it's important to do both, right? So deciding how you want to test a feature, deciding where the boundaries between testing are, I think that's a very key step in ensuring code quality. So I have this philosophy in mind where you should test front end separately, test back end separately, and you should not be testing back end when you're doing front end. For example, when you're testing the front end, you should not be testing whether or not we get the right back end code, right? You should only be testing if the front end works as expected, given some dummy input. So, but that is based on my experience and the kind of software that I've worked on. Maybe for your software, what works is a full-scale integration testing, right? The only person who can decide that based on your software is you. So deciding how you want to do a unit test with integration, I think that's a key part. And another part is making sure the testing is always done before you merge something. So when you have a CI/CD pipeline, it's important that testing is not just done right before you push out a feature to the users, but also keeping it a part of your CI/CD process so that whenever you make a build, if something is wrong with the build, the tests fail so that you get live feedback. Okay, as a part of my CI/CD process and something's wrong, now I know exactly where to fix because it's a part and the exact spec can fail. So I think that's really important. And beyond the functionality part, having the different types of testing, testing for security measures, testing for the UX, is something that definitely the programmer thinks, oh, everything as expected is working, but you have somebody, maybe the product owner, testing for the UX part of it, and they're like, this date picker, it does not give me the dates I expected to. You are giving me dates for starting from today, but this date picker, it's for my birthday. So maybe it's better, and depending on who it's targeted to, maybe it's better if the birthday date picker starts 20 years behind or 30 years behind, right? So those kind of user experience things can be something that we as developers just don't think about. So another layer of testing that focuses on these different parts, I think that's a very key aspect of testing. And another big part of testing that I feel we often overlook is the performance side of it. Now, can we really test performance? I I don't think you can really test for it, but considering performance and considering the kind of data that you expect and having some test scenarios for that, I think that's an ideal way to make sure that the code you write is performant, and also it comes in for the long term. It's not just for the data that you have today or tomorrow, but in the long term, can this application handle the level of data we expect it to have? So thinking about those questions when you create your testing philosophy, I think that's a very important part of code quality. And last but not least, the code quality agreements for the team, right? So as I've been mentioning, all of these things are basically steps that your team needs to ensure. So what do I think that the code quality agreements for the team is? So here I'm going to give again an example of how we did it. So what happened was about a year back, we realized in my team that, okay, our code quality is not bad by any metric, but we want to improve it, right? How do we do that? So we sat down, we had this big blowout one-day workshop where we sat down and we were like, what are the key parts that's always going wrong? And we built up this agreements, This is the dev team's code quality agreements. And in that, each point was, okay, so we are going to decide that instead of imperative, we're always going to use functional programming. That's the methodology that we want to follow. Every single case in which somebody writes a code and I think it's imperative, I'm going to point it out in the code review process because we want to use more functional programming, right? So that kind of agreements that you want to have in your team, and the way, maybe you have a certain way that you want your files to be named, or a certain way in which you want your files to be structured, right? All those definitions should be done as a team, and ideally it will be done earlier on in the process, but sometimes it's not. So I can give you another example. The decision to move from JavaScript to TypeScript, I would think that that's one that really impacts code quality. Now, again, it comes from my experience as a web developer, and I'm not sure, for example, what the analog would be in Java, but these are when you work in a team and you decide we are going to use this, deciding the impacts of that and deciding exactly how we want to tackle some of the challenges that come with it. I think that every single member of the team should be contributing to it and having the agreement. I think that really solidifies that down the line, when you have a disagreement, you guys can look back and be like, okay, we agreed as team to do this. Now, if you're going to change that, let's decide on a good reason to change it, right? So you have it in place and you have it as a process. And I think at the end of the day, as I mentioned, it's a team thing. And one part of being a team is that you have a process and the process is relied upon. So that each individual, they don't have to spend extra effort thinking, how do I do code quality today? Because you take some time initially, you set up the processes that work for you, and down the line, maybe the first week or the first month, you guys have some hiccups because you are still ironing out the differences. But 3 months down the line, 6 months down the line, that process is defined, that process is set in stone, and you always go through it, and it becomes a habit, right? Each person, from the tech lead down to the intern, they know exactly what they're doing because the process is defined, and we know exactly what to do. and it just becomes a part of your day to day. So let's look at the new workflow that's going to happen, right? You're going to start a new story. Right before you start, you check, oh, is my the feature that I'm going to work on, does it have any tech debt associated with it? Should that impact the estimation in any way? Well, no. Well, I move on. And then I build the feature. And then I have a code review coming up. But we already have the code quality agreement as a team. So we already built the feature with good quality. And during the code review process, we see, okay, should anything be changed to fit the code quality agreements that we already have? No? Okay, we already have agreements. I've passed the code review. What's the next step? Testing. So we go through the testing method, the new testing methodology that we have defined. We see if this fits everything in that. Okay, it fits everything. Now, once that's done, you can be a lot more confident in your code because you've already spent the effort into defining the quality, and the next step is, it's just, okay, the next step is not release it into production. The next step is putting it into staging and more testing, but you can be more confident in the code quality that you have because it's not just dependent on one person, and you don't worry about the quality changing depending on who wrote the code, right? So I would say that the code quality depends on the least experienced member of your team, and this is basically a framework so that you can ensure a base level of quality for every single member of the team. And as I said, this, I would believe, makes it more of a team sport in software, and it is a process that I think will help everybody and every code base have the best shine ever. And that's basically it from my side. I hope you found some points that were really helpful for you. And please, if you see me around, do come. I'd love to talk about code quality and the different points that I just mentioned. That's it from my side. Thank you for being a lovely audience. Thank you.